Welcome back, and it is the Corbett 5-a-day higher plus, and we're on to the 2nd of Feb. Let's go with the first question. Now, as you watched yesterday's video, definitely feels like these questions are getting a little bit harder, and at the very least they're changing some of the topics, so well worth going through each one of these. First question. First question is one of these where it's a technique. The technique here is, I call it easy or hard, but I don't mean easy as in simple. I just mean it's a straightforward one. There is no plus or minus in the denominator, so therefore I'm just going to multiply top and bottom by whatever the surd is on the bottom. In other words, the denominator surd. That's going to be root 3 here, so that's going to give me 2 root 3 on the top and 3 on the bottom, and so therefore I have 2 root 3 over 3. You could also write this as 2/3 root 3. That of course is exactly the same thing. Either way, question done. Next question. Oh, I don't really like these questions. So this is a understanding velocity versus time graph, and I need to, let's see what we're doing. So here's a velocity time graph. First 60 seconds, calculate an estimate for the acceleration, calculate an estimate for the total distance. All right. Thing about a velocity time graph is if you calculate the area, you get distance, spell it correctly. And if you calculate gradient, you get acceleration. So pretty much you say, can you do a gradient? Can you do a distance question or an area question? Now, what does it want? Calculate an estimate for the acceleration after 5 seconds. So 5 seconds is here. I'm going to do an over the top dot. So I want to get a line as long as I can, which is going to make a triangle as large as I can, which means I'm doing the biggest change in height over the biggest change in length. I'm going to zoom in here because I need to get this scale correct so you can see what I'm doing. So I'm going from, what is that? That's 10, 14. So to be clear what I'm saying, so that's 14 across 16 up. So I'm going up in twos. And this one here is a bit easier because this is 0 across and 10 up. So this is 0, 10. So in other words, I'm doing the gradient between those 2 points. So now my rise is going to be 6. In other words, 16 minus 10. And my run is 14. And so it's going to be 6 over 14. Do I get my calculator out quickly? 6 over 14 is going to give me 3/7 or 0.43. Now, it is a context question. So I also need to take account of what my units are. So that is going to be meters per second, otherwise known as meters per second squared. Question done. Next question. Okay, this one's going to be a bit of a pain. Typically, it will say when it says calculate an estimate, it might, so I'm looking at this bit here, it might say by using 5 strips or 4 strips, whereas here it's giving me no information at all. So I'm going to just use the tens as my guide. So what I'm going to do is divide this into different sections which are 10 seconds apart. And then what I'm going to do is choose the shape that best fits the curve that's within that space, if you see what I mean. So in other words, here, in fact, actually what I'm going to do is I'm going to do it in red because then you can see what I'm doing. So here I've got a trapezium. Here I've got another trapezium. I've got another trapezium here. That was not drawn very well. Another trapezium here. Another trapezium, and then I've got another trapezium over here. In other words, I'm going to have to work out the area of quite a lot of trapeziums, which is going to be a little bit tedious. So let's start doing it. I might then just forward the video a bit so you can see my end solutions. In order to do it, a trapezium, so the area of a trapezium is a half times the height, well, each of my heights are 10 because they're trapeziums on their side, times by whatever the y value is at the start and whatever the y value is at the end. So I'm going to call that y0 plus y1. So if I do the first one, again, I'm going to then forward the video so you don't have to watch me do it all. So it's the first one, A, is going to be a half times the height, which is 10, multiplied by, and then I'm going to zoom in. So multiplied by the height of this trapezium here, which I'm going to call it 10, just to make the numbers easier. So the height 10, and the height here is 12.4, and then I'm going to add these together. So it's going to be half times 10, 12.4 plus 10, and that's going to be the area of my A bit. And let's just then continue and do the rest. And this last one equals 120. Now, just to be clear, what I've done, because I sort of skipped through that and the video worked, is this is the half times the height times the y value at the start and end of each trapezium. Then I've worked out the value and I add all of these up and I get 569. Go back, it's in meters, so therefore it's going to be 569 meters. Now, 2 things. In a real exam, it will make it clearer how many strips to use. I strongly doubt in a real exam you're going to have to do 6 strips because it's really time consuming. It took me a good couple of minutes to go through, do it accurately. Secondly, in a real exam, you're going to get a much better line whereby it's more clear what the Y values are. Obviously, you can't do this on a computer screen, but even doing it on an iPad, it's quite difficult to be accurate. And thirdly, you'll get a range of values. So it's probably going to be something like 550 to 580. It's a fairly decent range. But the point is here, which is of course the point of these videos, is you've understood the technique. So that's what matters. Either way, 569 meters, error under the curve. I do it by approximating different shapes. Next question. All right, so good old algebra back, thankfully. So now I've got a solve the simultaneous equation. If you see me do these before, I'm going to call that equation 1, that equation 2. I'm going to put equation 1 into equation 2, which is going to give me x squared plus, instead of y squared, I'm going to write x plus 3 squared. And this is equal to 29. And then if I expand the quadratic, so I'm going to do that up here, because I don't think this is going to take a lot of space. That's going to be x squared plus x squared plus 3 times x is 3x doubled is 6x plus 9 is equal to 29. And let's tidy this up. So that's going to be 2x squared plus 6x. 9 minus 29 is minus 20. So I can simplify this again. Well, that equals 0 to x squared plus 3x minus 10 equals 0, which means it's going to be x minus, well, 10 is 5 and minus 2. So it's going to be x plus 5, x minus 2 equals 0. In other words, x equals 2 or x equals minus 5. Now I need to answer the question because solve simultaneous equations means I need the x values and the y values. So let's write that over here. So if x is equal to 2, using this equation here, y is 2 plus 3, which is 5. So that's going to give me 2, 5. If x is equal to minus 5, then y is equal to minus 5 plus 3. So let's write this into minus 5. Minus 5 plus 3 is minus 2. So my answers to my question are going to be 2, 5 and minus 5 minus 2. Quick aside, you should hopefully know that the second equation is a circle and the first equation is a straight line through the circle. So really I'm finding out where the line meets the circle. Good question. And next question coming up. Work out an estimate for the median. Now, if you do international GCSE, you don't need to know how to do this. You just need to know the class. But either way, it's a good thing to learn because you'll need to know it for A level. You may have seen me do this before, and if you haven't, I'll explain why I'm doing what I'm doing in a second. I don't write a cumulative frequency column. I write it like this. So the first class, or the first line or first row, is between 0 and 7. The next row goes from 7 to 17. In other words, it's 7 plus the 10 in between. Then 17 plus 53 is going to give me 70. 70 plus 25 is going to give me 95. And 95 plus 5 is going to give me 100. I quite like the fact it's a nice number. Suggests I probably added it up correctly. Now, the difficult bit. The median is the 50th thing. Imagine lining them all up. The median is the one in the middle, so I'll go along 50. Why is it not plus 1? Because when I have continuous data, I don't add 1. Let me just make that slightly neater. So the 50th thing. The 50th thing lies in between 17 and 70. This is the hard bit. If you've not seen this before, watch it a couple of times, check you're okay. I want the 50th thing. I'm starting with 17 things in the classes before, so therefore I need to move along another 33 things. In the overall class, there are 53 things. This is the important part. This is the fraction I need to move along that class. That class goes from 8 to 12, so in other words, I need 50 minus 17 divided by 53 as a fraction of 4. Then I need to add on the original 8 I'm starting from, so that's where I start my median from. So in other words, think about it just in terms of a graph, like a cumulative frequency graph. So my data does this, my 50th is here, I need to start at the start of my class and go along to the 50th. I'm working out how far to go along. Either way, get my calculator out. So 50 minus 17 is going to give me 33. Divide it by 53, so I want 33 53rds of the way along. Multiply by 4, which is the distance of the class. Add on to the original part of the class, and I'm going to get 10.49 centimetres. Now again, if that's the first time you've ever seen that, that is quite difficult. Watch that a couple of times, but it actually makes some sense if you think about it. Usual thing in video, it's a little mix of questions today were quite good, weren't they? So I enjoyed today's questions. As ever, do like, subscribe, any comments, leave them below, and I will get back to you, and I'll see you for the next one. Thanks all.